To put simply, link state routing works this way. Each router implements the routing algorithm. It's going to wait until the total information of the network is in place. Then it calls the extra algorithm. At the end of the calculation, we get the least cost path from this router to every destination possible in the world. So that is essentially the shortest path tree. Now that router being the root of the shortest path tree, we'll see there are multiple branches out to the rest of the world. Taking one branch, it gives you the shortest path to a certain set of destinations, another branch to another set of destinations, yet another branch to yet another set of destinations. And so, from the tree structure, okay, we can construct the forwarding table, and that is how the forwarding table is calculated in the control plane. Next is just to install it into the data plane. Now, the only part I'm going really quick without mentioning much is this: how we get the total network information so we could apply the extra algorithm in the first place. That is done through this link state broadcast. Each node, okay, in the network is going to generate link state report based on very local information. That includes the ID of the node itself, the ID of the immediate neighbors, and the cost, okay, on the link to these immediate neighbors. Okay, so these are the local information. Node, the neighboring nodes, and the link cost to the neighboring nodes. So all these local information is going to be in the link state report coming from the node. This link state report is going to be broadcasted, meaning, okay, going out through the entire network, being received by all other nodes. So all nodes eventually will receive link state reports from every other node. Okay. And these link state reports from every other nodes, including the node's local information, is going to be used to restore, okay, the total network. Let me give you an example to illustrate how that is done. We have a very simple network here, only 4 nodes. Okay, you see, U connects to V, U connects to W, U connects to X. Okay, so if we are node U, okay, and generating node U's link state report, it's going to contain this: the ID of the node itself. Yeah, there are 3 neighboring nodes, V, W, X, and the cost on the link to these nodes. 5, 3, 7. So U to V, link cost 5. U to W, link cost 3. U to X, link cost 7. Similarly, V is going to generate its link state report, which is going to contain only one entry. It connects to U, link cost 5. The link state report from W should look like this: 2 neighbors, U and X, cost being 3 and 2. Link state report from X is contained 2 entries, U and W, link cost 7 and 2. So each of these nodes, U, V, W, X, is going to broadcast their link state report, and every node in the network is going to receive its own local information and every other node's link state report. Therefore, node U here is going to receive the link state reports from V, W, and X, which we know already look like this. The way to restore the network topology is this. Okay, node U knows the local information. It connects to V. It connects to W. It connects to X. Cost is 5, 3, 7. Now, seeing node V's link state report, it knows that V and U is connected. Cost is 5. V, U, I'm U, so I know, okay, and the cost is 5. W's report is going to tell, okay, the cost to U is 3, which you already know. Oh, W is also connected to X with link cost 2. So W connect to X, link cost 2. X report says I connect to U, so X connect to U, you already know. X reports also that it's connecting to W, link cost 2, which you already have. And you know manage to reconstruct the total network information from receiving link state reports from all the nodes in the network. And it's contributing also so that other nodes receiving link state reports can also reconstruct the total network. So you see this one here, U connecting to VWX. Yeah, isomorphic, okay, of the network there. So that was the last piece of the puzzle, link state routing. Other problems you see here. Now you know a little bit about the link state broadcast. Yeah, some of you might see this. These link state broadcasts, it's going to travel the entire network. And it's coming from every router, right? So you have n copies of these packets going to n nodes. The bandwidth consumption is again at this scale. And to store the topology information in the router, right? So we discussed the complexity of Dijkstra algorithm. We only talk about the time complexity. We have not yet talked about the space complexity. It's also huge, right? In the worst case, you have n nodes fully connected to every other node. Then you have what? N square number of links. You need to store costs, okay, for all these links. Ugh. Not very scalable when the network goes big. When n goes